Greetings to all. Today we are going to see the introduction to the interesting integral calculus. Integral calculus has its origin 2500 years before. It has a very long back of history and it was invented by the Greek mathematicians. In the earliest year, integral calculus was being used as an idea, not in the form in which we are using today. The Greek mathematician Euclid, and Archimedes laid the foundation for the modern day integration which we are using now. Can you identify these mathematicians? Yes, the first one is the Greek mathematician Euclid, who used the method of exaction, a precursor to the limit procedure which we are using now to calculate the area and volume. And the second one, of course, is the mathematician Archimedes, who came very close to the modern day calculus. So what is this method of exaction? Let us have a look about that method. So initially, the Greek attempted to find the area of semicircle or circular region using the method of exaction. Here you can see a circle. To find the area of circle, they inscribed the known polygons inside the circle and they attempted to find the area of circle. They started with a triangle, quadrilateral, and here in the first circle you can see a pentagon. When you inscribe a pentagon inside a circle, you can see some space leftover between the circle and the edges of the pentagon. In the second circle, a pentagon is replaced with a hexagon. And of course, you can observe that the space between the sides of the hexagon and circle is bit reduced than the first one. And in the last circle, the hexagon is transformed into an octagon. When the hexagon becomes octagon, the space still reduced. So in this way, they inscribed an n-sided polygon inside a circle and approximately get the area of circle, very closer area to the original area. So this is called as method of exaction. And this is the basic idea of the integration which we are using today. This was developed and given a definition in the form in which we are using today. So the basic foundation was laid by the Greek mathematicians. So now we are using the integration in this sense, right? Just to find area under a curve y is equal to f of x from a given point A to B. To find that area, we will divide the region into rectangles, say of width delta x, So when I reduce the width delta x, right? So you are getting the next image. You can observe that in the first image, the area between the curve and the rectangle, leftover space, is more. Whereas if I reduce the width delta x, if I reduce the width, number of rectangles will be increased. So if the number of rectangles is increased, the region between the curve and the rectangles get reduced and the area becomes approximately closer. In this way, by reducing the delta x much smaller, by making delta x much smaller, or by making delta x approach 0, we can cover the entire area with rectangles, for which we can find the area. Area of a rectangle is given by length into breadth. So this is the concept which we are using today. Limit n tends to infinity, summation I is equal to 1 to n f of xi into delta xi. This f of xi into delta xi gives area of each rectangle. Adding the area of all the rectangles and allowing n to become infinity. That is, by covering the area with infinitely many rectangles, we can cover the area under the curve y is equal to f of x. And that is called as the integration. Integral a to b f of x dx is nothing but limit of the summation. If it exists, we call it as integration of f of x between the limits a to b. This sum is called as Riemann sum, and this is what we are using as integration currently. So next we proceed to see. Hope you can identify the mathematician. He is none other than Isaac Newton, who gave us the differential calculus. And this is Leibniz, who is another contributor to the differentiation part of the calculus. You may be wondering why suddenly I made a shift from integration to differentiation, right? And the interesting fact is that we all know integration as antiderivative. But the interesting thing is that integration came into existence first, then only they have invented the differentiation part of the calculus. And the credit goes to Newton and Leibniz. Then why we are calling this integration as an antiderivative? Where is this connection came between differentiation and integration? And this is the magical theorem which connected integration and differentiation and which have made the integration so easy as we are learning now. It is the fundamental theorem of calculus. If f is continuous on a comma b, then the function g defined as integral a to x f of t dt, then g dash of x is nothing but f of x. So this magical theorem of calculus gave the connection between differentiation and integration, after which we are calling integration as antiderivative, and we have from the basic formulas of differentiation, we are using the basic formulas of integration. In the next video, we will see the proof of fundamental theorem of calculus and other important concepts of integration.